Okay, this is Objective 8 in Unit 2 for Honors Math 3, and we are doing systems of inequalities, which will involve graphing. Now, as we are doing these, the graphing, we're graphing functions. There will be at least 2 and probably 3 at most, usually not 4. I'm just kind of giving you some general guidelines here at first, and then we're going to do some sample problems. Two things you have to consider as you're graphing the two extra things as you're graphing the functions. One, is it a solid or dotted curve? And it's dotted if it does not include the equal sign. It's solid if it includes the equal sign. And so that's pretty easy. The second thing that we have to consider extra is where do we shade? Now, if it's in the y equals form, then there will be a top side of the curve and a bottom side of the curve. And if you think about it logically, if your y less than, the lesser side of the y's is the bottom. So this one would be shading below, shade below the curve. This one is in y greater than, and this one's shade above. And if you happen to be in the x equals form, so if it's x less than, well, the left side is where the lesser x's are, so shade to the left. And if it's x greater than, the greater values of x are to the right, so shade to the right. Now, ultimately, the only place you actually shade overall is where the intersection of the shade is for all of the inequalities that are there in the single problem. So if it's just 2 of them, you just shade where the intersection is for the 2 of them, or if there's 3 of them, then you shade where the intersection of the shade is for all 3. Okay, we're going to do some sample problems right now, but the sample problems are actually a couple problems from the worksheet. So go ahead and get out worksheet 8 right now because we are going to be doing at least a couple of the problems. Okay, so I thought we'd look at problem number 2 from the worksheet. When we're doing these, it's going to be some pretty decent graph paper that's there in front of you. Okay, so problem number 2, we've got a parabola and also an exponential function. Now the parabola is dotted because it doesn't have the equal, and the exponential function is a solid curve. Now we need to be pretty precise with these sketches, and we need some good lattice points. Okay, so the parabola vertex is at 0, 1, and it's opening down. So 0, 1, and it's open. If we went 1 point to either side of the vertex, the a value is -1, and so there's 3 pretty good points. Now, because we need to be very accurate, it might actually be good to plug in a couple more points. And so if we input 2 and a -2, we actually end up getting -3 as the output for both of those. Okay, and it's a parabola opening down, and it is dotted, so okay, now because it's y less than, we will be shading below, but don't shade anything yet because we need to see what's happening with the other curve. So if we do the other curve, exponential function, it's shifted down 3, and so normally we're at elevation 0 with that, so the horizontal asymptote's at elevation -3. But let's get some actual points here. How about 0? We get -2, 1, we get -1. So 0, -2, 1, -1. And let's do one more. Let's do 2, 1, 2, 1. Now this one's solid because it's got the or equal part, so it starts off pretty much at almost at elevation -3, goes through those points and then keeps going up very quickly. Okay, and we are shading below that one as well because y less than. So we're shading below on both of them, and we're looking for the intersection of the two sets. So where do they have the shade in common? Well, the part that they would have in common is actually below the exponential and below the parabola. And so we're looking at something kind of like this. You don't have to really color it all in, but you do need to make it obvious where the shade actually is. Now, if there is a solution, and there's not always a solution, but obviously this one has a solution. If there is a solution, then it says name 2 points that are in the solution set. But I'm going to actually ask you about a couple, 2 or 3 of the points and see if you can answer yes, it's in the solution set, or no, it's not in the solution set. So what about the point 0, -2? Is that in the solution set or not? Well, 0, -2 is right there on the border, and it's on the solid curve, and the solid curve means that we can actually touch it. It's the less than or equal to, and so yes, that point is in the solution set. What about the point -2, -3? Well, again, it's right on the border. It's definitely below the exponential function, but it's right on the border of the parabola, and the parabola is actually a dotted, and since it's dotted, that is not included in the solution set. We can't actually touch it, so no, this one is not a point in the solution set. Let's try another one of these. Sometimes there's more than a couple of curves. So let's flip it over maybe onto the back side. And let's take a look at, let's go ahead and take a look at number 10 here. Okay, so number 10, oh yes, number 10, because that's got one of those x, it's in the x equals form. Okay, now x equals, just if it was x equals 1, it'd be a vertical line. Well, it's still a vertical line, but it's a dotted vertical line at -1. And so I'm just going to go ahead and do a dotted vertical line at x equals -1. Now, if we were to shade, now, because it's x equals, there's a left side and there's a right side. Well, it's x greater than. Well, which side is greater than -1? Well, the right side is greater than -1. So right now we will be shading on the right side of that dotted line. Don't shade yet. We have to wait because we're going to do the intersection of all 3 solution sets. Okay. So next we have y greater than or equal to 2 to the x. Okay. And so that's, it has not shifted. It goes through 0, 1. It also goes through 1, 2, and 2, 4. And it's a solid curve. It's greater than or equal to. So comes off here really close to elevation 0 and goes through those 3 points and then just keeps on going up very quickly. Okay, and finally we've got the last piece, which is a line. Okay, y equals mx plus b, so the slope is -1 and the y-intercept is 1. So they have a point in common. This is a solid line, slope of -1, so down 1 over 1, do it 2 or 3 times. Okay, and I need to draw that line. Okay, so solid line. Okay, now let's figure out if they have any place where they share all that shade. Okay, so we're shading to the right of the vertical line because we only want the x's that are greater than -1. We are shading above the exponential function, so above the exponential function, but to the right of the vertical line. And then we're shading below the diagonal line. So below the diagonal line, above the exponential function, to the right of the vertical line. And there is this very small region right there where there is an overlap of all that shade. Okay, so again, I'm gonna ask you a couple points maybe that, is that point in the solution set? Well, how about the point 0, 1? And if we look, we can see that 2 of the 3 curves are intersecting there. And notice that both of those curves are solid. And so, yes, 0, 1 is a point that is in the solution set. How about -1, 2? And so -1, 2, again, is the intersection point of 2 of the 3 curves here. And but I also noticed that one of the curves, the line, it is dotted. And so because you cannot touch it dotted, and we're only taking the intersection, meaning where it's shared by all 3, -1, 2 is not a point that's in that solution set. Now, you might be saying, well, there's hardly any points. No, there's an infinite number of points that are in there. It's just there's not that many lattice points that are in this solution set. In fact, it looks like there's only the one lattice point that's in this solution set, but lots of fractional or decimal ordered pairs that would be in there.